that the center of you don't assume that all the weight is in the center. And so let's try this one, example 9.
So, how would we start?
Let's see. So I'd say with the reactions. So this is maybe reaction at S. Or suppose we could do it going the other way. Let's do it going the other way. So Sam and Tasman, he's 20. No, sorry. Sam has a mass of 35. So he's going to be 35 G. How about Tasnim?
25 G.
So that's going to be 25 G.
And is the actual plank 25 G as well?
So the plank itself is 25 G. I think that would have to be somewhere on the right of the midpoint so that it's balanced. Let's see. M is at the midpoint. So we're calling. Oh, sorry. No, C is there. So C, the center of mass is there. So that's where that 25G is. So it's not in equilibrium then, I suppose. Okay.
Wait, but how do we work it out if it's not in equilibrium?
I think, what would you say about the reaction here?
You do 1.8 times.
Nope.
Does the reaction have to be equal to 35G plus 25G plus 25G?
Yep.
So 85G, the upward force.
G. So 35G plus 25G. Non-uniform plank. 25 length 4. Plank is pivoted at M. The center of mass is at C. Sam has 35. Sorry. Yeah, where must Sam sit so that it is in equilibrium?
Okay, so do we work the force of Tamsin, and then it has to be equal to the same as his, so then we can work out the distance maybe.
So you just take moments about any point and then go from there. So which point do you want to choose?
If we do a moment about C, can you do 1.8 times 85G?
Let's start with moments about A.
Okay, so 35G times 1.8.
No. Did you do 35G because of Sam?
Ooh. Wait, is Sam on the left?
I think so. You're right. Why would they do that to me?
Yeah, that's it. Okay, so For a
So,
moment about A.
hang on. Sam has 35. Why would you call them S and T and then do them not in alphabetical order? So that one's 25. Yeah, so that one's cheek does man every day. Right.
So now would we do 25G times 1.8 for the
Yeah.
moment of A? So that's 25 times 9.8 times 1.8, which is 441.
Okay.
And then, yeah, so if it's in equilibrium, then the force from Sam has to be equal to that too. So 441 equals G times 35G. So
Slow down. You're forgetting. Just take moments. So 25G times 1.8. We have a reaction at M.
which is 85G.
Oh, you cheat this, man. Yeah, okay. 85G times
1.8.
nope. The reaction at M is M for midpoint.
Oh, 2.
Yep.
Which is equal to 1666.
Okay.
So then that one goes anti-clockwise, and the first one we worked out goes anti-clockwise too.
Mm-hmm.
So okay, so Sam has to balance out both of those together. So do we add them together?
Mm-hmm.
Then we have 2107. So now, so if Sam's force has to be equal to that, just his, then 2107 equals 35G times D.
Sure.
So then if we do 2107 divided by 35 times 9.8, then we get 43 over 7.
So you tell me when you think you have a final answer.
Let me just check. I think it's 43 over 7, which is a decimal number, 6.14.
Okay. Let me check. So 85 is 2. And then it's minus alpha x 35 times 9.8. Shift solve. Let's go with lucky 7. Was that something like that?
Yeah.
Let's hope we're right. Let's see. So he's saying that's from one end. 25G. So they're taking moments from there. Hang on, what was the question asking us to find? To be horizontal. So it's okay. Hang on. How big is this plank? Plank is only 4 meters.
Yeah, I'm confused.
Let's see. Did we do something? It's So that's 1.8. That's 25G. That's 25G. That's 35G. So 25G, a reaction at M, is it? 25G times 2. Why is it 25G? 25G times 2. Yeah, that's okay. And then 0.2 times 25G. Yeah. They removed the reaction. They took moments about M so that they could remove the reaction at M. Were we wrong about the reaction at M? Reaction at M, 25, 25, 35, 3, 4, 5, 6, 7, 8, 85G. Is 85G not correct somehow?
I thought that it had to be balanced in the end, so it has to be equal to the bottom forces.
It does. So this reaction here, 25, 25, 35, 25, 25, 35. So the reaction at N is just 85G. 25G times 1.8. Hang on. Taking moments about M. Taking moments about M. This one is going anti-clockwise. Is that right? No, this one's going clockwise. So that's negative. That's why. So 25G times 1.8. That should be negative. Then this one should be positive. And then 35G should be negative. So just clockwise and negative. So this first one, 25G 1.8, that's negative. The last one is also negative. And the middle one is positive. Shift, solve, lucky 7, 3.571, 3.57. Yeah, so clockwise negative, anti-clockwise positive. That's all we have to watch out for.
Okay, yeah.
Other than that, don't overthink these. Just kind of take moments about some point, clockwise negative, anti-clockwise positive, and let the calculator do the work. Any questions there?
No.
Okay, let's see. Is this similar? Before we do that, are they all going to be a bit like this? Let me see this. Right, exam question. I don't make it easy. Let's try this. Point C.
Okay, so this one, the center of mass is in the middle. If it's uniform, right?
Does it say uniform? Aha.
Yeah.
Okay. So what are the forces?
24G down, and then another 15G down. Yeah.
Blank AB as mass.
Okay, so it's an equilibrium. So we find the tension in the rope attached at B. So is that the same as finding a moment about B?
Tension at A, tension at B.
The force.
Okay, so how would you go about finding the tension at B?
Okay, so well, the moment equals the distance times the force, but we don't know the forces and we don't know the moment, so
how did we do previous one?
use all of the forces, add the other ones to find it. So if we do a moment about A, then we have, wait, is it to C or to the middle?
Just pick A. Keep it simple.
But the distance, would it be up to C or to the middle point?
Distance of what from what?
From A.
To what?
I don't know if it should be to C or to the middle.
Take moments about A. Every force, every distance.
To B.
Every force, every distance. I see three forces. There's a force at C, there's a force in the middle, and there's a tension force at B.
So, the moment about C would be 1.4 times 15g.
Yeah. So you're using the wrong words. I think that's what it is. But you're doing the right method. So 1.4 times 15g. Is that positive or negative?
It's going clockwise, so positive. No. If it's positive, it's negative. So minus 205.8.
Okay.
And then to work out the moment at A,
So you did 1, 2 to go.
at A and B.
1 down, 2 to go. Take moments about A.
So, but would we use the forces that are going down or TA? We don't know.
All of them.
Oh, so the moment about A is the tension time, no, plus 24g plus 15g times 2.4.
Kiddo. Okay, proper way of doing it. What is the distance from A to A?
0.
So that's 0 times tension at A. Then we said it was minus 1.4 times 15g. How about next one?
2.4 times 24g, and that's a minus as well because it's going clockwise. So then we do plus 0 times the tension at B.
No. What's the distance from A to B?
4.8.
Yep.
Oh yeah, because it's about A.
And so if you did that times that, that times that, that times that, that times that, and added them all together, it's in equilibrium. What should you get?
0.
0. You have your equation. Solve your equation.
So the tension at A gets cancelled. And then so I got minus 793.8 and then plus 4.8 times tension at B.
Okay.
So then 4.8 TB is equal to 793.8. So to work out the tension, we would do 793.8 divided by 4.8.
Sounds about right.
Okay, so we get 165.375.
Sounds about wrong. Hang on.
Oh,
Is that what you got? 160.475?
5. No, I got 165.375.
Let's see. So I did 1.4 times 15 times 9.8. And that's a minus. I did minus 2.4 times 24 times 9.8.
Yeah.
And I did plus 4.8 times that x. The whole thing's equal to 0. And calculator solved it for me. And that's what I got. Let's see. They're saying it's roughly 160 to 3 sig fig. Hang on a second. They're not saying 3 sig fig, they're just saying 60. 160, they just rounded it to 3 sig fig. So you actually did 1.4 times 15g and all that stuff?
Yeah, I did it right. I typed in what I typed in before and I got the answer that you did. But before I didn't use the x and the solve function. Like I wrote everything in my calculator apart from the 4.8 times the tension at B. So I got an answer and then I just tried to do plus 4.8 times the tension at B, but I don't think that works.
It does work. It's just in the kind of mess of, 1.4 times 15 times 9.8, writing that down, you probably just made some little mistake somewhere. Sometimes it helps to kind of to simplify the numbers a bit, kind of helps you to understand things, and sometimes it doesn't. You just have to decide when it's easier to do it by just chucking it on the calculator. B.
So if before the tension in both of the ropes would have been equal, so they both would have been 160. But now A is 25 newtons greater.
My guess is no. My guess is the tension in A was originally greater. If there was just a midpoint, that'd be true. If C was on the midpoint, that'd be true. But C is to the left of the midpoint. That's the beauty of taking moments about one of the unknowns. It eliminates it because anything times 0 is 0.
Mm-hmm. Well, I guess then.
That'd be a 25 greater. So if this one on the right is called tension in B, what could you call the one on the left?
Tension in B plus 25 newtons.
Yep.
So how would we work out the moment again, but without using the midpoint? Like the distance.
You could find the tension in B first.
So tension B would be, so the moment at B would be 0 times.
Problem with that is you'll have two unknowns. You'll have the tension in B and you'll have the distance. Anyway, you can get the tension in B without needing the distance.
Do the moment about A first.
Then you still have two unknowns. You have the distance and you have the tension in B. Maybe you're onto something. Then you'd have simultaneous equations.
Okay.
No, not okay. That's more work than I'm willing to put in. What's an even easier way to get to tension in B?
Don't know.
What if you'd never met a moment in your life? How else could you get tension in B? Any equation, anything you know that you could use that involves the tension of those ropes?
No.
There is. You already used it. You did it here.
Balance.
Nope. Very first thing you did.
Oh, the upper force.
Bingo.
So 15 plus 24g is 39g. So does that 39g equal 2tb plus 25?
Sure does.
So if we simplify, then we get 382.2 is equal to 2tb plus 25. So then 2tb equals 382.2 minus 25, which is 357.2. So then we divide that by 2 to get 178.6.
178.6. And no offense, but you're a gigantic nerd girl. I'm just putting the whole thing in calculator. Hope you're happy. Fine, you're much smarter than I am. We still got the same answer. Let's see. So tension in B is 178.6. But they asked us for the distance for this new something or other. The new center.
So if would you use... So... So if we get a moment about A,
Yep.
then a moment about A is equal to 203.6 times D.
Times the distance from A to A.
Oh, 0.
Yep.
So that cancels out. It'll be 0.
0.
I don't understand.
You have to find the distance. So they moved C.
Yeah.
Okay. Find the distance to C.
So
Last time you did minus 1.4 times 15g for C.
So now we do minus D times 15g.
Correct.
But then to find D, we need to know the moment.
So do the rest of them.
Oh, like add all of them?
Yep.
Okay, so...
That's called taking moments about A. That's what you said.
So we do 203.6 times 0.
Correct.
And then plus 15 times 9.8 times X.
Yep. Or D. You called it D a second ago.
Yeah. And then
And what direction is that gone?
that's going down that way, so clockwise, so that will be negative.
Yep.
Okay. And then now we do plus. We did the moment at A and then at C. And then, so now do we do M?
Yep.
So if we add 2 times 24 times 9.8, and that is, yeah, that's also clockwise, so that would be negative 2.
Mm-hmm.
And then last we do B, so add 178.6 times 4.8, which, and then we do shift solve.
Except I'm concerned. A second ago you said 2. You tricked me. You said 2 times 24 times 9.8.
Oh yeah, so that should have been 2.4, right?
Yeah. And then it is shift solve time.
I accidentally deleted it from my calculator, so I'm trying to type it in again.
Why would you snake this man like that? Let's see. Shift solve. I'm going with lucky 7. 1.99. Okay, so that's the distance from A. They said find the distance of the mass of the plank from A. 1.99. Okay. So it looks like the new C place is at 1.99. Let's check it. So that's part A. 2.77. I'm blaming you for this one. Hang on, 178.6. So far so good. Taking moments about A. 15G times 1.4. 15G times 1.4. Wait a second. Did they move the other one from us or something? So they moved... Hang on. So a load of mass 15 kilos is attached to point C. So C is the stable one. And they moved the M as a non-uniform rod. Yeah, I suppose I should have known that. Because it's not in the middle anymore. It's somewhere else. So if it's uniform, the 24G, the 24G is the mass of the plank. Yes. So the 24G isn't in the middle anymore. It's the 24G that moved, not the other one. Snake this, man. Right, hang on. So 178.6. Okay, do it all again. Except this time it is the M that has moved somewhere. 24G.
Okay, so
15G.
I got 2.7, 2.8.
2.80, let's say.
Yeah.
2.80. They said, wait, 2.7. Yeah, 3 sig fig 2.77. Yep. Grand.
Okay.
Any questions about that malarkey?
No.
So for this one, you had to use the simple thing first to get to tension in B, which is total upward force equals total downward force. Otherwise, if you'd gone straight to moments, you would have gotten two unknowns. Moment about A is like A is the hinge. Everything is revolving around that. So distance from it to itself is 0. And so to its own force is just going to be 0. That's going to be eliminated. Minus that one, plus that one, it equals 0. That's how we do these. Hold on. Okay, let me go back. I skipped this one. This time there's no diagram. How do we do this?
Okay. So the rod is 3 meters long and the force down is 20. So so
I think it's something like that.
yeah, magnitude of the reaction at C is 3 times the magnitude at D. So that's like a ratio distance. Okay, so we want to find the distance for the centre of mass. So we start by taking moments around A, which would be, I don't think there's a force at A.
There isn't?
What would I do? Where do I use the 20 going down?
You tell me.
The 20 would be at the centre, so do we write like a new force in to represent the centre?
This is 0.5. This is 1. If the magnitude direction at C is 3 times bigger, my guess is that the centre is much closer to C than to D.
So
I'm just going to chuck it like that.
and then at that point, that would be the 20. Or is it just 20 or 20G?
You're right, 20, yeah.
Okay, so if we do moments around A, it would be 0 times 1. And then plus, so the ones going up have to be equal to 20. So RC plus RD equals 20. And then, so do we do 20 divided by 4, and then RC would be 15 and RD would be 5.
Very good.
So if we do that, then we on calculator plus 15 times is 1. And that would be going, if it's about A, it would be anti-clockwise, so it's positive. And then the centre would be 20 times X. And that is clockwise, so it would be negative. And then add, so 5 times 2.5. And so 5 times 2.5, that is anti-clockwise, so that's positive. And then B is 0 times 3. And then solve. And I get X equals 1.375. So
1 3/8, I think. The centre of mass to A, 1.375 meters. Yep, 1.38.
yay.
Grand. Any questions there?
No.
Smashing that. Let's see. I can't be having you feeling too good. Let's see. Yeah, let's do it.
So the distance A to C would be 10 minus X.
That would be from B to C, I think. There's a gap here.
Okay. Oh, C is in the center.
Yeah.
So A to C is 5 meters.
Mm-hmm.
So to find the value of x equilibrium. So if we did moments about A, we would have force going down is 30g, 30 times 9.8 times 5, and that is gonna be
How'd you get times 5?
times 0, so it's about A.
Or you can take moments about C and then it's times 5. It's up to you.
Is it easier to do it about C?
You could try it. Let's try moments about C.
So 5, and then that is going to be anti-clockwise, so it's positive, and then plus, so C is the center of mass, but does it have anything? Or would it go up there? The upward force, that has to be equal to 30g plus 50g, so 80 times 9.8 times 0.
There you go.
And then for the other guy, it's going to be 50 times 9.8 times alpha x, and that is going to be, yeah, clockwise around C, so it's negative. And then I think that's every force, so solve. I get x equals 3.
3 meters exactly.
Yeah.
3. Yep. Okay. B.
That the center of mass is in the middle of the beam.
Yes. That the entire weight and mass of the beam is all in the center. Okay. C.
Okay, so now he's 4 meters, and we want to find the distance percent of the beam from C. Okay. If we do moments about A, then we would have 30 times 9.8 times 0 plus so we don't know, so C is moved, or no, C is still in the middle. No, it's not. Okay, no, C isn't, it's not uniform anymore, so
Hang on though. The pivot is at the center. C. Do they mean the middle or the center? I think C would stay where it is. Is that wrong?
but he moved, so we still can use C then as the middle.
But does this beam weigh anything?
It 25g.
Does it?
Yeah.
Where do you see 20? Oh, there it is. Aha, yes.
So
yeah, sorry, go on.
So I did the moment about A, which was just times 0 for Sophia, and then for C, then we would do the 25g, so 25 times 9.8 times 5 from A.
No,
And
9.8 times. C is in the middle.
yeah.
25G is in the center. That's what's weird. So
Oh,
there's a difference between the midpoint and the center of mass. So if
there's a
it's
center.
non-uniform, yeah, if it's non-uniform, the mass can be all focused somewhere else.
Okay, so we can't do that then.
Yeah.
So that is that the bit that we do times x?
Yep.
Times alpha x. And if that's clockwise, so it would be negative. Now we have the point about Sophia, and then the new center, and then we don't use C. So then plus
I think we do use C.
oh, C goes up. Okay, so 80. Oh wait. Is it 80 or do we have to add 25?
You tell me.
G. Well, okay, yeah, we want it in equilibrium, so we would have to do that. So it would become 80G and then plus 25G.
Yep.
And then all of that is going to be times was it times 5 from A, and then plus 59.8 times, now he's 4 meters from C, so would it be times 9?
I believe so.
Okay, so shift solve.
Slow down. You can always press left to go back to what you were doing. If you, that last one is a plus or minus.
He's A is going down clockwise. Oh, so it's minus.
Yeah. So you said plus. I don't know if you actually put in plus or minus.
No, I didn't put in the minus.
Okay.
So now if I do, I get x equals minus 9.8.
That doesn't look happy, but let's see. They see there's a bit of ambiguity with this one because the difference between the center and the midpoint is a bit like, what is the question saying there? But I think what's happening is C is in the center, so that's 5 meters still. I think that the center of mass must have moved to the left because this guy has to move to the right to counterbalance it. He used to be 8 away from Sophia, 3 away from there, and now he has to be 4 away. And so that's what my thinking is, that C stayed the same, but that this now center of mass, like the triangle, the pivot, stayed in the center, but this stayed in the middle, but that stayed there. Let's just check, because you're always doing this crazy stuff. And by the way, I'm a dummy. There's an X underneath the on button, so I don't need to do alpha X every time.
Oh yeah.
There you go.
I didn't know.
Let's see. So this one goes, that's plus 5 times, those guys are 80, so that's 105G. 5 times 9.8. And then that guy is minus 9 times, was he 30G? Sophia is 30G and he's 50G. Roshan 50G. 50 times 9.8. I don't know if that's male or female. Shift, solve, lucky 7. I get minus 3. Doing what you did. You put in the 0 thing at the start, did you? Like the Sophia stuff?
Yeah.
So maybe that's... See, I know it's going to be 0, so I just leave that blank. Let me just make sure. Did I start with a minus? No, I didn't. So Sophia... No, hang on. This one should be minus, shouldn't it? The 25G one? That should be
Yeah.
minus.
Why?
That should be minus. Shift. Solve 7. I get positive 3.
Mm.
So it's just some typo or something, is it?
Yeah, but I'm not sure.
Press left,
Where?
see if you can find it.
Um.
You can always try deleting. So just press left and then delete the bit that will become 0.
So wait, what bit makes it 0?
I think you put in Sophia. So you did like 30 times 9.8 times 0 or something.
Yeah.
So maybe delete that
So
out.
should I get rid of that?
Like it shouldn't make a difference, but I think it's just... It'll make it easier to find where you went wrong.
Fish. Oh, I still have the wrong answer.
Is it an identical answer?
Yeah.
So that's just to kind of clear the clutter. So now find where...
Wait, I think maybe if I type this in better. Now I have positive 3.
Okay, I just realized. So that's the difference from A to this one. So this is 3. And so they want the distance of the center of the mass of the beam from C. So what's that distance?
2.
Okay, that's our assumption based on the crazy stuff. Yeah, 2 meters. There we go. Yeah. So did you find what the mistake was? Did you just type something in
I
wrong?
typed in the bracket where I did 80G plus 25G.
Mm-hmm.
I think something with the brackets just was wrong or something.
Okay.
Because
So
I changed it to 105 and it worked.
yeah, and you can see how sometimes it does kind of help to simplify sometimes. So sometimes it does help to simplify, sometimes it doesn't. Yes, so let me just yeah, so that's right. Any questions about that?
No.
Okay, so once again, I didn't do the angle stuff, but we did this one. So this one is similar. This bit over here on the left is very heavy. This bit on the right is much lighter, and so you have to say, some stuff like that.
Okay.
Center of mass.
A half.
Let's just see, is there any stuff after? Hey, tilting. Yep, it's more stuff. So anything in particular you want to do next time?
Not yet, but I'll message you if there is something.
Okay. Any questions for me in general?
No.
All right. Well done, Keelan. You did great. I look forward to trying again next week.
You too. Have a good week.
You too. Bye bye.
Bye.